Today, I'm talking about another method to find volumes. Another method is cylindrical shells. I will take an example. For example, y equal 2x squared minus x cubic and y equals 0 enclosed region and revolved about y-axis. So we can draw this graph. This graph intersection to x-axis is this is x-axis is this is 2 0 equal x square 2 minus 2 this is 2x square 1 minus x 1 over 2x. So we can graph this function. This function is this is x-axis and this is the y-axis. X intersection is 0 and 2, so we can draw this graph like this: 0 and 2, and this is like this. So this region is revolved by y-axis, and we can get this. This is minus 2. And this is 4 over 3. Local maximum is minus 4 over 3. So we can we try to find the volume enclosed this area. So this is a washer. This is in order to find the volume, firstly we have to know cross-section area and the height. The cross-section area is this area. This is the washer, and height is dy. So enlarge this is like this. This is washer, and the height is dy. So this area, cross section is this area. This area is, so area is, this is the radius of the small circle x1, and this is x2. This is x1, and for example this is x2. The cross section area is pi x2 square minus x1 square. The height is dy, and y is from 0 to so this is equal to a and 0 to a. So we have to know the x1 and the x2, but this on this curve to finding x1 and x2 is very, very hard. So we can find the volume like the washer, but this is very, very difficult. So we need another method to find this volume. So the volume of the solid obtained by y-axis, the region under curve y equal fx from a to b. For example, we take this example again. This is the x-axis, and this is the y-axis, and this is 0, 2, and minus 2. Like this. So we like this. This is a cylinder. This we enlarge this cylinder. This cylinder is like this. So this area like this. This is like this. Instead of find the washer, we find this area. This is called the cylindrical shell. So we cut this with a knife. So this is because this is the x-axis. This is the dx, and this radius is x. and this height is this is fx, and this is y equal fx. This cylindrical shell can be rectangular parallelepiped like this. Cut this. We try cut this part. This is like this. This can be this is like this, and this length is 2 pi x. 2 pi x is the length of this sucker is 2 pi a, and this length is fx, and this is dx. So this small volume is 2 pi x fx multiply dx. So this is integration for x. So x is from a to b. This is a to b means this is a to b is from, in this case it is 0 to 2. So this method is called cylindrical shell. Instead of finding volume by washer, the washer finding volume by washer method is very difficult. So we need another method. It's called cylindrical shell. In need cylindrical shell, using cylindrical shell volume, we can find the total volume. So I'll take an example. Find volume of solid obtained by rotating y-axis bounded by x equal. Yes, this is above example. This is we can find. This is the x-axis. X-axis. This is y-axis. This question. In this question, it's very hard to find volume by washer method. So we need another cylindrical shell method. This is -2 and 2. Like this, and this region is divided by y-axis, and this is like this. Like this. So we can use in cylindrical shell and a cylindrical shell. This is a cylindrical shell, and this length is fx, and this length is x, and this length is dx. So this is this cylinder. This cylinder withdrawn like this. X, and this length is dx, and this is fx. Fx is this is 2x squared minus x cubic. So this cylindrical shell volume is this is we cut this part and unfolding this volume, and we can get rectangular parallelepiped like this. This is 2 pi x, and this is 2x squared minus x cubic. This is dx. So this volume is a differential volume. The differential volume is 2 pi x multiply 2x squared minus x cubic dx. From x is from 0 to 2. This is total volume. This is the volume by using cylindrical shell. So we can calculate this integration. This is the 2 pi integral from 0 to 2 to x cubic minus this is 2 pi is out of this integral, and the 2x cubic minus x to the power of 4 dx. 2 pi, and this is 1 over 2 x to the power of 4 minus 1 over 5 x to the power of 5 from 0 to 2. So it becomes 2 pi 1 over 2 multiplied 2 to the power of 4 minus 1 over 5, and the 2 pi and this is cancelled, and 8 minus 32 over 5, 2 pi multiply 8 over 5, and this is 16 pi over 5. This is the answer. This is the volume. So next example is find the volume of the solid obtained rotating about y-axis between y equal x and y equal x squared. X-axis and this is y-axis. First, y equal x and y equal x squared. X and y equal x squared is like this. This area rotated y-axis, so we can get this. At this volume, we don't need to use cylindrical shell. We can find the volume by washer. I will find the volume by both two methods. First, with washer method. This is like this. This is like this. This is y-axis, and the cross-section area is this. Cross-section area, this area, and the height is dy. Cross-section area is this length and this length. This length is y, and this length is square root y. So we can find the volume. This is cross-section area is pi square root y square minus y square. The square root y is greater than y because y is less than 1, and it's a cross-section area, and the height is dy, so it can be integration. The volume is the cross-section area multiply the height, and the height is from 0 to 1. This is volume. So this is pi 1 over 2 y square minus 1 over 3 y cubic from y equals 0 to 1. 0 to y equal 1. And this is pi 1 over 2 minus 1 over 3. And this is pi over 6. This is the answer. I will find the volume by using cylindrical shell. Second method is cylindrical shell. And the graph is like this. This region, the cylindrical shell is like this. This is cylindrical shell. This, and this length is dx. This length is the x, and this length is, what's this length? This length is the x, the y minus y square. It means this is x minus, this is the way. This is a cylindrical shell, and we enlarge this graph. We enlarge this graph, draw this graph more larger. This is one. And this region, and this is the x-axis. This length is this. This is for example, h is, this is h, and this is dx, and this length is this is x, because this curve is y equal x. So what is h? H is this value minus this value. What is this value? This value is, this is y equal x, this is y equal x square, x minus x square. The volume is cylindrical shell is, we can cut one part, and unfolding this cylindrical shell is rectangular parallelopiped, and this is dx, and this is h is x minus x square, and this is x. So x multiply x minus x square dx integration. This is 1, x equal from 0 to 1. So this is the volume. So we can calculate this integration is integral from 0 to 1 x squared minus x cubic dx, and this is 1 over 3 x cubic minus 1 over 4 s to the power of 4 from 0. No, I'm sorry. This is 2 pi x, because this length must be the length of the circle, and this is 2 pi. So we can, this is 2 pi, this is 1, and 1 over 3 minus 1 over 4. 2 pi multiply 1 over 12, and this is pi over 6. So the result is the same, both using washer method and cylindrical shell method. The next example is, find the volume of the solid obtained by rotating the region bounded by y equal x minus x square, y equals 0, it's rotating about 2. We draw this graph. This is a x-axis, and this is y-axis. The rotating axis is x equal 2. And this graph, the intersection to the x-axis is x equals 0 and x equals 1. And like this. So rotating this, and we can find this. This is 3, and this is a 3, and this is 4, and this region is very hard to find volume by washer method. So we find the volume by using cylindrical shell, and this is cylindrical shell, and like this. This is a dx, and this is x, and this is f of x. So cylindrical shell. So the differential volume is 2 pi x fx dx, and integration from x equal 0 to 1. So we, as you know, this is a cylindrical shell like this. This is a cylindrical shell, and this is like this, and this cylindrical shell. This is x, and this is dx, and this length is fx, the y equal x minus x square. So the result is integration from 0 to 1, 2 pi x, x minus x square, 2 pi, not this is x. So this length is d is 2 minus x is d. So this is d is 2 minus x, correct? So this length is d is 2 minus x is d. So this is 2 minus x and x minus x square dx. This is the volume by using cylindrical shell. So we can we can calculate this definite integration. This is 2 pi integration from 0 to 1, and x cubic minus x squared minus 2x squared is minus 3x squared, and plus 2x dx, and 2 pi and 1 over 4 x to the power of 4 minus x cubic plus x squared from 0 to 1, 2 pi 1 over 4 minus 1 plus 1 cancelled, and this is pi over 2. This is the answer. So today we studied cylindrical shell to find the volume. Generally, in previous time we found the volume by using washer and another method, but sometimes it is very difficult to find volume by washer method or other method. We have to use cylindrical shell. Today, thanks for listening to this video, and see you next time. Bye bye.